On Friday, January 19, 2024, Japan formally asserted its place as a space power by successfully landing its SLIM spacecraft on the lunar surface. The SLIM lander launched in September 2023 touchdown according to telemetry readings from the Japan Aerospace Exploration Agency. JAXA's President Hiroshi Yamakawa confirmed the successful soft landing and the spacecraft's capacity to communicate signals after descent. However, something strange occurred which could jeopardize the mission's future. That's quite tragic, isn't it? Follow me in this video to find out what happened and how it could affect the mission. Motivations. Everyone understands that humanity wants to expand its frontiers to the solar system and beyond. As you may have heard, the aim is to start with the moon. Colonies of trained and carefully selected astronauts will be the first to set foot on our stunning natural satellite. Then it will be time for ordinary citizens of the world, like you and me, to put on their suits and go. If everything goes well, humans will most likely be regarded as the solar system's first conquerors, given that no other forms of life existed before to us capable of leaving their home planet and living their lives on another celestial body. This will most likely take a long time, but something is going underground in the scientific world. Space agencies throughout the world are already putting money into ambitious efforts to send men to the moon. However, this is an extremely difficult undertaking to complete. Imagine investing a significant amount of time, resources, and money only to have your probe crash due to a failed soft landing on that regolithic surface. Or far worse, imagine a piloted spaceship incapable of landing in the precise location. In that event, the entire mission would be jeopardized and the crew members would be devastated because they would be unable to carry out the experiments for which they have been trained. Before any human may step foot on the moon, extremely precise landing techniques must be tested to ensure a safe and profitable expedition. This is where a mission like SLIM, proposed by Japan, comes in useful. SLIM's objectives. The Smart Lander for Investigating Moon Mission, or SLIM, seeks to investigate the lunar surface and undertake vital experiments and investigations to improve our understanding of Earth's celestial neighbor. Starting in 2023, SLIM's adventure began with a rideshare with the X-ray Imaging and Spectroscopy Mission, or XRISM. After separating from XRISM, SLIM carried out translunar orbit injection burns in October 2023. By December 25, 2023, it had smoothly entered lunar orbit, paving the way for a historic soft landing on January 19, 2024. Notably, SLIM distinguishes Japan as the fifth country to accomplish this lunar achievement. SLIM originated in 2005 as the Small Lunar Landing Experiment satellite. Fast forward to 2013, SLIM was one of 7 proposals for ESA's competitively chosen medium-sized focused mission. In 2014, it advanced to the semifinals, confirming its birth. From April 2016, SLIM became a full-fledged JAXA project with Mitsubishi Electric winning the contract for spacecraft building in May 2016. The mission's primary goal was to present a pioneering demonstration of accurate pinpoint landing technology on a celestial body with gravity. With the availability of high-resolution imaging data from satellites, the emphasis has switched from landing somewhere on the moon to landing exactly at a specific point. Unlike traditional moon landings with kilometer-level accuracy, SLIM has developed pinpoint landing technology with astonishing 100-meter accuracy. The SLIM Working Group has worked extensively to study and create unique technologies that allow for such high levels of navigation accuracy. Innovative solutions include proposed algorithms for practical crater detection and recognition, which combine to build an image-based navigation system that can be deployed on existing space-qualified FPGA devices. A new landing radar system, carefully validated in field flight testing with a breadboard model, improves the mission's capability. The research also investigates the detection and avoidance of potential obstructions near the landing location using camera footage. The Sea of Nectar was selected as a landing location. This is a plain that contains the Scioli impact crater. Scientists believe the Sea of Nectar was produced by previous volcanic activity. SLIM has successfully reached the Sea of Nectar, and if everything goes well, it will analyze the composition of rocks in the coming weeks, potentially assisting scientists in discovering the moon's genesis. SLIM also brings lunar excursion vehicles, or LEVs, outfitted with a variety of instruments, such as thermometers, radiation monitors, and inclinometers. LEV-1, a lunar rover, has a hopping mechanism, but LEV-2, or Sorikyu, a small rover created in partnership with Tomy, the Sony Group and Doshisha University can change shape for lunar surface exploration. Japan's successful SLIM touchdown undoubtedly represents a watershed milestone in its space exploration efforts. With a soft landing on the moon, the country has joined an elite club of nations, demonstrating its technological strength and scientific accomplishments. The project not only has the potential to advance our understanding of the moon, but it also demonstrates Japan's dedication to pushing the boundaries of space exploration. It's a shame if something goes wrong. No energy, no party. Unfortunately, something went wrong. Specifically, the solar panels on SLIM's mini rovers are unable to generate power, which limits their functionality. Despite this setback, JAXA has confirmed that the rovers were successfully launched and are transmitting data back to Earth. However, SLIM's solar battery is not producing power and is predicted to last only a few more hours. The present goal is to acquire as much data as possible about the lunar landing and exploration while using the remaining battery life. The issue now is that, for the mission to be judged totally successful, space officials must check whether SLIM achieved a pinpoint landing or not. Given that the rovers cannot create energy, this is difficult to determine. JAXA believes that, while more time is required, it was most likely achieved based on the study of data revealing the spacecraft's movement until landing and its capacity to transmit signals afterwards. But let's assume JAXA is correct and a pinpoint landing was made. This is how it happened. Pinpoint landing. SLIM, also known as the Moon Sniper, began its descent at midnight Saturday. According to the space agency, it reached an altitude of approximately 10 kilometers above the lunar surface within 15 minutes. Once at a height of 5 kilometers, the lander entered vertical fall mode. At 50 meters above the surface, SLIM was anticipated to maneuver parallel to find a safe landing location. SLIM, which was equipped with pads on each of its 5 legs to lessen the impact, intended to land near the Scioli crater. The primary feature of this mission is SLIM's capacity to scan the moon's surface and identify familiar locations known to astronomers in previous space missions. SLIM used its inbuilt navigation system to precisely steer its little spacecraft to land within 100 meters of its intended target. The spacecraft uses a 2-step landing procedure, in which the main landing gear is the first to make contact with the ground. To guarantee stability, the spacecraft turns forward before its front leg gently touches down, allowing SLIM to rest safely and smoothly on the moon's surface. In light of these accomplishments, Japan becomes the 5th country to successfully land on the moon. Prior to Japan, India was the 4th country to accomplish this accomplishment in the previous year. China made its 3rd successful moon landing in 2013. With the Apollo 11 mission in 1969, the United States became the 2nd country to reach the moon, although Russia claimed the title of first in 1959 with its robotic lander. Other recent moon failures. Other recent missions have demonstrated how difficult a safe landing on the lunar surface can be. During a landing attempt in April last year, Japanese company Aspace Hakutoar lunar lander dropped 3 miles or 4.8 kilometers and crashed onto the moon. These animations depict the landing site before and after impact. A Russian mission known as Luna 25 also crashed in August, marking the country's first effort to return to the moon since the dissolution of the Soviet Union. This resulted in a 10-meter crater on the moon. Last but not least, Astrobotic's Peregrine mission, which launched on January 8th, was the first lunar landing mission to launch from the United States in decades, but a critical fuel leak prompted the lander to abort its mission just hours later. However, this time, no crash on the moon occurred. On January 18th, the spacecraft re-entered Earth's atmosphere and burned up. The controlled re-entry occurred over open ocean in the South Pacific. At this point, you might be wondering why it is so difficult to get to the moon when we have already done it. Well, you see, there could be a variety of causes for this. Take NASA as an example. During the space race, NASA spent a whopping $25 billion on Apollo. It failed repeatedly before reaching the moon. It now has 70 years of institutional expertise and a culture centered on designing, building, and testing spacecraft. However, under its new Commercial Lunar Payload Services (CLPS) program, the agency hopes to save costs while also stimulating the U.S. space sector by paying private businesses such as Astrobotic and Houston-based Intuitive Machines to deliver its experiments to the moon. The trade-off is a higher risk of failure, which means more lost missions. All of these companies are quite new, and by comparison, they are carrying out these missions on a shoestring budget, says Dr. Joshua Rassera, a research associate at Imperial College London. But the method should pay off, he claims, because businesses learn from their mistakes. It still ends up being cheaper over the total number of missions, he goes on to argue, even if the first few maybe crash. Furthermore, every space agency, public or private, is rebuilding or starting from scratch. It's know-how because, remember, know-how is more than just the theoretical and practical knowledge required to do something which anyone can learn, but also the experience gained. Certainly, the engineers who worked on, example, Luna 24 almost 47 years ago have retired. If Roscosmos hasn't worked on a project like this in decades, it's practically like starting a lunar mission from scratch, despite the fact that one of the lunar program's probes, Luna 10, first orbited our natural satellite in 1966. Simply put, going to the moon has always been difficult, and it is likely to stay so for many years to come. Space exploration is a challenging, expensive, and breathtaking effort. Alright everyone, that is all for this video. Thanks for watching. What are your thoughts about the SLIM mission? Please let us know in the comments below. Plus remember to like, share, and subscribe. I will see you next time on the channel.